Good morning, everyone, and welcome to our Grade 10 Science class. So, for now, we're going to discuss about the Boyle's Law. It is also called a Marriott's Law. It's a relation concerning the compression and expansion of gas at constant temperature. It is formulated by Robert Boyle in 1662. It states that the pressure of a given quantity of gas varies inversely with its volume at constant temperature. In equation form, it's Pv is equal to K, which is a constant value for the temperature. Here in our picture, at the initial stage, there's a volume, which is a 4, let's say ml, 4 ml in the syringe with a pressure of 1.0 atmosphere. Holding the temperature constant in 300 Kelvin, we can particularly state that when we decrease the volume, we put it into 2, the pressure or the particle of gases in the syringe started to compress because gas is compressible, which is in kinetic molecular theory. As we increase or decrease the volume of the container, the pressure inside the container increases and it becomes 2.0 atmosphere. So in regards with this idea, we can state that there's an inverse relationship between pressure and volume, holding that the temperature is a constant variable. Let's try to figure it out using a PET simulation program. Okay, so we're going to use gas properties and let's try to check whether we can see it clearly all throughout this time. Okay, so I need to put particle of gases in here. We have the two types of particle, the heavy and light particles. But for the sake of our demonstration, I only need to use the heavy particle. Holding the temperature constant, we cannot change it all throughout. And we have here our container is 10.0 nanometer with our particles inside on it. The pressure is or becomes 8.6 atm, 8.6 atmosphere. But if we try to manipulate, we need to adjust the length of our volume, put it might be around 5.4 nanometer. The pressure from 8.9 becomes 17.5 because the collision of the particles are greater and thereafter the pressure in which the particle bumps up in terms of the kinetic energy also increases. That's why we can demonstrate it with an inverse relationship. Okay? How about if we try to put using a calculator in a meanwhile? Let's try to have a sample problem. Okay? For a while. So let's try to solve this problem. A gas occupies at 12.3 liters at a pressure of 40.0 millimeter per mercury. What is the volume when the pressure is increased to 60.0 millimeter per mercury? So let's try to answer this problem. I need to put the calculator here on the side. Use calculator. Okay. So a gas occupies somewhere related with, let's try to have a graph or using the Gupta method. Given are 12.3 liters, which is the initial gas volume. Let's say is volume 1. We also have pressure 1, which is equal to 40.0 millimeter per mercury. Okay? Next, after that, what is the volume when the pressure is increased So at initial side, we increase our pressure into 60.0 millimeter per mercury. What will be our new volume? So that is our problem. Let's try to analyze. Here, 40.0, we increase the pressure. So thereafter, automatically, the idea of inverse relationship, probably our answer should be less than 12.3 liters because we increase the pressure. We increase the pressure, it decrease the volume, right? So let's answer it using this formula. P1 V1 is equal to P2 V2. So initial pressure and final pressure, initial volume and final volume. Let's try to give a shot for it. So given our unknown is the V2. Our formula to get the V2, P1 B1 is equal to P2 V2 divided by both sides by you get the value of V2. So P2 V2 cancel it out. Then V2 is equal to P1 V1 divided by P2, right? So let's try to solve. Go unknown formula. This is our formula solution. So V2 is equal to the value of P1, which is 40.0 millimeter per mercury, multiply by 12.3 liters all over the value of 60.0 millimeter per mercury. Okay, so let's try to put it in our calculator. So our new volume is 40.0 multiplied by 12.3, 462 divide by 60, and the answer is 8.2. Looking for the significant figures when we are dividing, so it should be three significant figures. So the answer is 8.20 liters. So let's try to put 8.20 liters. So thereafter, the statement of inverse relationship is correct indeed. Since we increase the pressure, we decrease the volume at the second half of our solution. This is P2. Okay, that ends up our discussion for the Boyle's law. I hope you learned a lot. Thank you.